Hi, my name is Jeff Gallimore. I'm the Chief Technology and Innovation Officer and a co-founder at Excella. Tell me if you've heard this story before. You go live with a production release over the weekend. The release was complex, involving changes to multiple systems that had to be carefully orchestrated. After going live, you discover there's a problem with the release because you start getting calls to the help desk from users. You start troubleshooting the issue and realize the problem involves the interconnection between two systems. The fix requires making changes to both systems, and it's an emergency because users are still calling the help desk, unable to do what they want to do. So you slam the emergency fix into production to get the systems back up, breathe a sigh of relief, and then try to incorporate the changes into the lower environments for both systems so you don't have the same thing happen again. This story happens in enterprises where systems are highly coupled and don't have the architectural features that could improve resilience. There is a better way though, and I'll share that better way through two stories. The first story involves a system we built that had many connections to other systems, both upstream and downstream, typical in many complex enterprise IT environments. Our system needed to make remote API calls to those other systems to do its intended job. When you create dependencies between systems and teams like that, it increases the complexity and risk and the potential for having customer impacting problems. We use two patterns to address that issue. One is called the circuit breaker pattern. The other is called the bulkhead pattern. Both of these patterns are intended to isolate problems in parts of the system and create what's called graceful degradation, which is in contrast to catastrophic failure, which leads to those help desk calls from users. Graceful degradation means the system still has limited functionality to do its job and serve user needs, rather than experiencing a complete outage. The second story is about going live with the system we built for a large federal program. At a date and time certain, the virtual doors would be open and people from around the world would be submitting requests to this system. As planned, we flipped the switch at the designated time and the requests started flowing in. I was actually there with the team during that release, and I noticed a spike in errors being reported on our monitoring dashboard. I called our tech lead over and quietly asked, is that spike something we should be concerned about? He said, nope. We've already created the fix and it's working its way through our CI/CD pipeline. It should be in production in about 20 minutes. Since we're also using an event-driven architecture, once that fix is in, we'll just rewind the event queue and reprocess all the submissions. No submissions have been lost and no users have been impacted. This story highlights both the power of continuous delivery and responding quickly to problems and the effectiveness of event-driven architecture in creating resilience. In today's complex IT environments, the two stories highlight the fact that architecture plays a powerful role in enabling fast flow of features and value and increasing operational stability and resilience.